Okay, so to start off the lesson today, you guys are going to be playing with this shape. On your device, you're going to create whatever shape you want. All you have to do is drag the dots. I'm going to give you guys about a minute. Create a shape. I'm going to tell you right now, try to create one that's a little bit more recognizable instead of one that's like crazy, because this shape is going to be your shape going forward for a few examples. Just a heads up, we learned that last period. So go ahead and play with your shape right now. Everybody is logged in to Amplify, correct? Ladies and gentlemen? Okay, go ahead and manipulate this and make whatever shape you guys want to make. And you guys can actually pull the dots to another dot if you don't need that many dots. So you guys got about 10 more seconds to make your shape. And then you guys are synced to my screen. So just a heads up, whenever I click next, it's going to move you to the next slide. Okay? So thumbs up when we're ready to go. Again, you guys got 5 seconds left, so finish up your shape. 5, 4, 3, 2, 1. All right. On this slide, you guys have a printer. You guys are going to be pressing the zoom out and zoom in buttons, and you're going to be hitting print and seeing what happens with the printer. So go ahead and start doing that, and then in your notes, you may want to answer these questions instead of in the text. You guys can do these in your notes. The reason why I'm having you do these in your notes is because you get to use these on the test. Okay? Technically, I could have you guys just type this up on here and give you credit, but does that help you on the test? No, especially since you get to use your notes on the test. So in your notebook, what are you guys noticing? What stays the same no matter what the zoom level? What changes? Go ahead and answer that in your notebook now. All right, so what do we notice? No matter what we do with the zoom, what do we notice about the shapes? Yes.
The shape stays the same no matter how much you zoom it.
Okay, so the shape stays the same, but what changes? Nice and loud. The size of the shape changes, right? So if I go all the way to like the bottom zoom and I print, it's a smaller version of the arrow that I made, right? If I go all the way to the largest one, now I have a bigger arrow, but the shape still stayed the same, right? So let's move on to the next slide. Now we have a broken printer. Go ahead and play with your broken printer and see what happens. Ladies and gentlemen, is the broken printer giving us the same shape?
No.
It is not.
I don't like it.
So there is a very important distinction between the correct printer and the broken printer. You don't have to write this down in your notes unless you guys want to, but we're clearly not getting the same shape, right? The lines are distorted or shape is coming out all deformed. So let's go to the next slide. Another broken printer. What do we notice about this broken printer? What do we notice? It's stretching our shape, right? But is our shape staying the same? Kinda, right? But it's shaping it, it's misshaping it. So this is what the importance of this whole lesson is. We're talking about scaled copies. Whenever you see bold words in the lesson, that's something that needs to be in your notes. So we need to write scaled copies down in your notes. You guys will have the definition for this later, or as I'm talking, you guys can explain. So scaled copies, what do we notice about the scaled copies? So we've got number 1 and number 2 are scaled copies. 3 and 4 are not. What are certain things that you guys notice between 1 and 2 and 3 and 4? Remember, you raising your hand and answering questions is your way of earning your participation points for the day. Your goal should be answering every single day at least one question.
1 and 2, like they look the same, but one of them is bigger, one of them is smaller.
Okay, what else? What else do we notice? Doesn't matter.
1 and 2 copy the original shape, only changing the size, while 3 and 4 distort the shape and the size.
So, when we're talking about scaled copies, you guys have all played on like Print Shop or like on Photoshop or Canva or something, right? So imagine grabbing a picture and like grabbing that corner and making it bigger and smaller, right? You're basically scaling that image. That's what it means to scale it. You're not making the image wider or smushing it down. You are scaling the image. So images 1 and 2 are scaled. It's the exact same shape. They're either bigger, which means they got scaled up, or they're smaller, which means they got scaled down. 3 and 4 are clearly not scaled because they are not the same shape. 3 looks like I kept this in my pocket when it went in the wash, and 4 looks like I tried to buy this on Temu. So they are not the same. Okay? They are completely different. So what is a scaled copy? With your group, talk to each other. What do you think the definition would be of a scaled copy? I told you guys to write scaled copy down in your book. What do you think the definition of a scaled copy is based on our conversation? With your group, go. Talk to your group. Again, anybody want to volunteer and tell me what they define scaled copy as? Yes.
Scaled copies are the same shape but different size.
Okay, anybody want to add on to that definition?
Bigger or smaller, it's like it stays the same, but just like different size. That's the scaled copy changed into different shapes or something.
Do we want to change the shape? So remember the shape. So what I've heard is the shape stays the same, right? The consensus is bigger or smaller, but it still stays the same, right? So imagine this. When we talk about everyone's heard of like replica stuff, right? So like when you guys like travel places, for example, I've never been, but if I've been to the Eiffel Tower, I'm pretty sure somewhere around there sells miniature Eiffel Towers, right? Some places may say it's a scaled copy, or it's a scaled replica. It's a one, I don't know, we'll pick a number, 1/100th the size of the regular one. Meaning if I took that one and I blew it up 100 sizes, it would be basically the Eiffel Tower. Maybe it's a 1/1000th. Maybe that would make more sense. So it's 1,000th the normal size, and everything is proportional. Everything is built exactly to scale, that if I were to scale it up, it would be perfectly fit with the Eiffel Tower. Some places do that, where they sell an exact replica of something in a smaller size. So we're going to skip this one. On the grid here, you guys have you have 3 shapes technically. We're looking at scale or shape A first, okay? The question is, which one is a scaled copy of figure A? Is it B? Is it C? Or is it both? Are both a scaled copy, or is only one a scaled copy? With your group, I want you to identify. Look, see what you see. You guys are allowed to draw on your copy if you need to count some things maybe, to explore. But I need you and your group to come up with an answer. Is B the scaled copy? Is C the scaled copy? Are both of them the scaled copy, or neither one of them a scaled copy? And then make sure you hit submit on this. With your group, go ahead and talk. Group 6, what did you guys decide on? 5? 4, what did we decide on? You decided on both? Okay, 3? Group 2? B? Oh, you said C was the scale? Okay, and then group 1. Okay. Ladies and gentlemen, the correct answer is figure B is the scaled copy. And here's a dead giveaway, okay? Group 5 saw something first, okay? I'll call on group 5 in a little bit. Group 5, wait. Those of you guys that said B, why did you guys say B and not C? What are some dead giveaways? Yes.
B is more slanted up like that.
Okay. So you guys noticed the slant line, right? Okay. What else did you guys notice? Anybody notice something different? Or make a different call? All right. Group 5, what was the thing that you guys noticed?
C's top angle is smaller than both B and A.
Okay, I can't zoom in on this more than I can, but you guys can. If you guys notice the little unit where the slant line goes through, you notice how much purple is in that one and how much red is in that one, and then you look here and that C is different, right? There's less in there. And if you look at this corner, the angle is different. This angle is a little bit bigger. So one thing you guys need to add into your notes, when you do a scaled copy of a figure or shape, all the angles stay the same. So when you make a scaled copy of a shape or a figure, all of the angles stay the same. That should be written in your notebook, ladies and gentlemen. So one more time, when you make a scaled copy of a figure or a shape, all the angles stay the same. Now, I will say this. I'm going to pause the recording really quick. Okay, so back to the recording. So the correct answer was figure B. Again, we got to look at every little thing. And then you guys are going to notice one other thing that you probably didn't catch. When we deal with scaling, we need to deal with a certain thing. We're dealing with proportional sides. So again, the word proportional is there. So that should be in your notes, ladies and gentlemen. Hint, hint. And corresponding. I'm going to read this statement and then I'm going to translate it into English. Okay. Scaled copies have proportional side lengths. This means that any two sides of the original shape form an equivalent ratio with the corresponding two sides of the copy. When part of an original figure matches up with part of a copy, we call them corresponding parts. So what this means is this. You guys notice here that this side length was how many units long for A? What about B? What about C? So those all matched up, right? So technically side A here could have been scaled up to either one of those. What's the side length unit-wise? If this side was 2 and then it became 4, if this side is 3, what should this bottom part be? So let's see. 1, 2, 3, 4, 5 for C, right? So we automatically can tell C is not a copy, right? Because can 3 become 5? And you guys said this side should be what, ladies and gentlemen? 1. It won't let me click. 1, 2, 3, 4, 5, 6. It is 6. So let me give you guys an example here. Let's say I have a rectangle. Okay? I have a rectangle. Here's my rectangle. My rectangle is 5 by 3 inches. Okay? Here is my scaled copy. This side is 15 inches. What's the length of the side that's missing if this is scaled? If this is a scaled copy, talk to your group. What should be that missing side there right here with that weird looking question mark? Talk to your group. If this side is 5 inches and this side becomes 15, this side is 3, what's the length of this missing side? Okay. Coming back in 3, 2, 1. Okay, ladies and gentlemen, what is the length of the missing side, ladies and gentlemen? Everybody just got that question wrong. Okay. Listen to the question. If this side is 5 inches, this side is 3 inches, this side is 15 inches, what is the length of the missing side? What did you all say? No, that's not what you said before. What did you guys all say when I asked it? What was the correct answer? Say it nice and loud, please. Ladies and gentlemen, if I ask you how tall you are you going to look me in the face and say 5? How tall are you? 5. What? You're going to say what, ladies and gentlemen? Okay. One of you is 5 inches tall? Okay. So, you're going to put the measurement. So again, the question was, what is the length of the missing side? And you guys needed to say what? Ladies and gentlemen. Okay. The correct answer is 9 inches. How did we get to 9 inches? Who can raise their hand and tell me why they said 9 inches? Rex. Oh, my bad. I don't know names yet. Rex, do you want to explain? You want to explain? Dave, do you want to explain? Jaden, right? Why do I suck at names? It begins with a B. Braden. Okay, I told you guys I suck at names. Braden, go.
The 15 was just multiplied by 3 so that you could get 15. So it was 5 times 3. So just multiplied 3 times 3 to get 9 inches.
There you go. Be aware that we just scaled it up 3 times. That doesn't mean that this rectangle and this rectangle are 3 times bigger. Because what's 5 times 3, everybody?
15.
What's 15 times 9? It's bigger than 15, right? What is 15 times 9? All right, let's calculate it.
I think I got it.
What is it?
135.
Yep. Okay. Is 15 times 3 135?
No.
So I can't say that this is 3 times bigger, okay? I can just say that I scaled it up, but I can't say it's 3 times bigger because technically the area doesn't change. While this is 5 and this is 15, yeah, I just made the side length 3 times bigger, but did I make the whole shape 3 times bigger? No. So that's the rule with scaling, just so you guys know. So these are corresponding figures, which means they're proportional. I'm going to pull something out of here. This is a pizza. If it doesn't autocorrect, it doesn't autocorrect. So here's a pizza. Why are you not autocorrecting? There we go. Okay. The shaded part is the part that I'm taking. How much of the pizza do I have, ladies and gentlemen? Okay. Now we split the pizza. How much of the pizza do I still have? I still have half, right? I have 2 out of 4, 2/4, which is still a half. If I keep cutting this even more, how much of the pizza do I have? I have how many slices out of how many slices? 4 out of 8, which is still half. That's what we're doing with the scaling. We're basically making a ratio that is still equivalent, okay? Which is what you guys just did with that rectangle. So, going back to this. So, this side is 4 units, right? This side is 2. This side is 6. This side is 3. These equal each other. Because the only thing I had to divide both of these by was what number, ladies and gentlemen?
2.
I divided them each by 2. When you guys did the rectangle example that we just did, you guys scaled it up. You guys said, okay, if this is a 5 by 3, and my next one has a 15 as the side length, or as the top length, the side length is what? And you guys all told me 9 inches after I corrected you. But you guys all told me 9 inches, right? So this is what proportional side lengths are. If you guys did not put this in your notes, you guys can do this later. I would suggest putting this in your notes. All right. On your device, you guys are going to tell me which ones are scaled copies and which ones are not scaled copies. Drag them to the appropriate thing. Go ahead and do that right now on your device. Ladies and gentlemen, we'll do this together since we're running out of time. Let's start with this purple one. What do we think, ladies and gentlemen? Scaled or not scaled? Why do we think it's scaled? Let's see. Scaled copy. Cool. What about this one? Why not scaled?
Because you can't multiply 2.5 with 6.
And what about 3 to become 5? So not scaled. What about this blue one? Oh, I'm hearing a bunch of... this one's a tricky one, huh? Okay, those of you guys that are not scaled, why? Oh, it lets me put them in either one, huh? So we have to check. Okay. And then what about the orange one? Not scaled? And this one? All right. Go ahead and submit your answers. Does it tell you guys if you're right or wrong or what? It doesn't tell you? All right, I'm going to pause the recording because I don't want to see. Hang on. So it is. So I know this one kind of threw us off. 4 can't become 5. Technically, 4 can become 5. 4 times 1 point. So this is where you guys are going to make ratios, right? Can 4 over 6 equal 5 over 7.5? And it can. All I did was this. I took 5 and divided it by 4, right? Which was 1.25. Okay? So what I could have done was this. I could have done 7.5 divided by 6 to see if it's still 1.25. Or if I multiply 4 by 1.25 to become 5, 6 times 1.25 should become 7.5, which it did. So this is scaled. Okay? This one's clearly not scaled because we have Pac-Man over here, and then we have Pac-Man ordered on Wish. So wrong. This one not scaled because, like you guys said, 3 could not become 5 and 2.5 couldn't become 6. If we divided them to check, they would have been completely different. You guys caught this tricky one that this was whiter on the copy than it was on the original, and this one is proportional. So we're good there. All right. So, do we really need to do the sketch playground? Let's skip that for now. All right. So show what you know. Click on the figure that is not a scaled copy of figure A. So on your own, click on the one that you think is not a scaled copy of figure A. Ladies and gentlemen, which ones did you choose? Which one's not a copy? D is, yeah, definitely not a copy. Okay, how do we know that it's not a copy?
Because there's a little snub on it, and like if you look at figure A, there's not a snub on it.
It's not the same shape, right?
Yeah, not the same shape.
What other one's not the same? F? Oh, it's a lot longer on the top, huh? Okay, what else we got? B? Why? There we go. It's got an extra square. It's longer here. Anything else? So we think C and E are scaled? Okay, let's find out. Figure B is not scaled. Figure D is not scaled. Figure F is not scaled. So good job. You guys all picked the right ones. You guys can reflect on the lesson. You guys can click on how you feel about the lesson if you want. It doesn't matter to me. What matters is that we look at what our workbook is. So this here, just a heads up, these are your vocab terms, okay? You guys can actually access this online. When I'm done doing this, you guys will have freedom to go back to it. So I would say copy this all down into your notes, please. Or later today, you guys can see this on YouTube. If you guys want to go the YouTube route, it'll be on here with me talking just like I am right now. You guys can pause it and then copy it. This should all be in your notes. Please copy this down into your notes. Okay? So I'm going to go ahead and stop the lesson.